Hey guys, hi. This is Nizam, your host at ICSE in one shot. So, how is all of your life going on? All fine, sorted. So, guys, what we are doing today is that we are solving the physics paper for 2019. Okay, so if you have not watched the previous session of physics ICC paper 2018, link is given in the I button. Just click on it, watch it, and then get back with this video because that's the first thing which we have done for this series, and now we are over here with the second part of the series. Okay, um, I would tell all of you that with before beginning this session, all of you please hit like this session if you're thinking the content is up to the date, and just subscribe the channel for more of such updates, and just share this video so that you help everyone out. Okay, so today's question is physics paper 2019 solved. So here what I've done is which of the questions are there in our further reduced syllabus. I have just ticked it up, and which are not there I've just cancelled it out. As you can see, question number one, first question is belonging to lever, so I've just crossed it out. Next, question number B, it states that two bodies A and B have got the masses in the ratio 5 is to 1, and their kinetic energies are in the ratio 125 is to 9. Find the ratio of the velocities. Okay, so here given it's ma by mb. Okay, so it's given to me 5 is to 1, so kinetic energy A upon kinetic energy B would be 125 is to 9. Ultimately, since Ka by Kb is half ma Va square upon half mb Vb square, which gives me ultimately ma by mb into Va square upon Vb square. Finally, you put these values over here, you would get it Va upon Vb. This whole square would come up to 25 upon 9, and then Va upon Vb would come root over 25 upon 9, ultimately 5 is to 3, which is your required answer. So the ratio of velocities of A and B is 5 is to 3. Easy to mark a question. See, these types of questions only you get in your board. So be very practical, understand your lessons in the given the book, read the notes very appropriately. That's the key point. Let's go forward. See, question is given, name the physical quantity which is measured in calorie. Obviously heat energy. Second question states, how is the calorie related to the SI unit of the quantity? We know that SI unit of heat of any form of energy, that is joule. Okay, and we have got a definite relationship between joule and calorie, which is 1 calorie equals to 4.2 joule. Simple. Next question, it states that define couple. Okay, now many of you would be thinking define couple has got a different meaning. Yeah, it has got a different meaning, but in physics what we define by couple is that two equal, opposite and parallel forces which is not acting along the same line of action, same line of force, sorry, they form a couple. Okay, then what is the SI unit of couple? Moment of couple, the SI unit is Newton meter. Okay, so either force into perpendicular distance between force applied to the axis of rotation. That's your formula. Okay, so let's go forward. Define critical angle. Now it states that critical angle is that angle of incidence in which in a denser medium corresponding to the angle of refraction in the rarer medium is 90 degree. This you need to keep in mind. Okay, next question is, state one important factor which affects the critical angle. Obviously the refractive index, the nature of the material. Next question, let's go forward. It's question number 2. Okay, it states an electromagnetic radiation is used for photography in fog. Identify the radiation. Obviously that is infrared radiation. Because of its high wavelength, the rays scatter less. That's the main property. See, that's the reasoning. Why is the radiation mentioned by you ideal for the purpose? So that will be the answer. Because of the larger wavelength, it's scattered least among the visible radiations and thus have a deep penetrating even in the fog. It was also used in the warfare times. Okay, Now, what is the relationship between the refractive index of water with respect to air and the refractive index of air with respect to water? So, if it's given to us in the question that the refractive index of water with respect to air is 5/3, then obviously we have to calculate what is air with respect to water, right? So this question would be solved like this, that since refractive index of water with respect to air is inversely to the refractive index of air with respect to water, they are inversely related. So that is the answer for your first question. Assimilating from there, we can tell that the second answer is gonna be 3/5, the reciprocal of the first one, which is nothing but 0.6. That's your answer. Next question you have: the specific heat capacities of a substance A is 3800 joule per kg per Kelvin, and that of substance B is 400 joule per kg per Kelvin. Which of the two substances is a good conductor of heat? Give a reason for your answer. So obviously the substance which is going to have the more specific heat capacity will easily acquire more amount of heat energy, but will take time. Okay, so which one will be a good conductor? Obviously the greater one. See the reason. Substance B is a good conductor of heat. The reason is that substance B has got a lower quantity of specific heat which acquires higher temperature as compared to substance B. Now, substance B at high temperature conducts heat from its surrounding rapidly. That is the main thing which you're gonna write in your answer. Next question states, a man playing a flute is able to produce notes of different frequencies. If he closes the holes near the mouth, will the pitch of the note produced increase or decrease? Obviously, when the holes near the mouth are closed, effective length also increases, so the pitch ultimately decreases, because we know the relationship between frequency and length is inversely related. So that is your answer for this question. Next question is given to you as this. This question would be provided to you. ABCD as a rectangular glass slab with critical angle C is equal to 42. Now see here, angle is given you 42 degree. Okay, so you have to complete the path taken until it emerges out of the block. So see one thing, the answer to this question is you have to draw a normal. Always we need to draw a normal, that's the property. So let's do it. You have to just draw a normal, and that's given to you as, this is given to you 42. So ultimately that would come to you at the 90 minus 42, which is nothing but 48 degree. So ultimately what we know, that when the angle of incidence is greater than the critical angle of that median, total internal reflection happens. Same is this case. So angle of incidence for first surface is 48 degree. So angle of reflection, total internal reflection, would be also 48 degree as marked over here. So at this point, you see this angle is going to be 42 and this is already 90, so this is going to be also 42. Ultimately this angle is going to be 42 degree, and we know when the critical angle becomes equal to the angle of incidence, grazing margins, or simply the critical angle, if it becomes equal to the angle of incidence, it's gonna pass just grazing the surface. So that's all, people. Next question states, question 3a, if the lens is placed in water instead of air, how does its focal length fluctuate? Let's change. Okay, this is very important question, by the way. So answer is gonna be the focal length increases. Let me tell you why. In short, I'm telling. Okay, when water is a glass is placed in water instead of air. Okay, so glass when it's placed in water, water has the higher refractive index as compared to air. So actually what's going to happen is that when from air to water it's placed, ultimately the focal length is gonna ultimately increase. That's the thing which you're gonna see. So let's go towards the next. The next part of the question is, which of the lens, thin or thick, has got the greater focal length? We know that for a thick lens, since it's thick, its power to deviate is more. It's gonna have the shorter focal length. So obviously the answer is gonna be a thin lens that's got the greater focal length as compared to a thick lens. Next question states, two waves of same pitch have got the amplitude in the ratio 1:3. What will be the ratios of their intensities? Obviously we know that intensity is square of amplitude, so ultimately that's ratio is gonna be 1:9. Next question, frequencies. We know that frequency is dependent upon the medium. It does not change until and unless you change the medium. Okay, so the ratio of frequencies is gonna be remain 1:1. Next question is, how does increase in the temperature affect the specific resistance of a metal? And number two is semiconductor. So first case, specific resistance of a metal. So this part is the specific resistance of a metal increases. Second part is specific resistance of a semiconductor decreases, because semiconductors resistance is ultimately increase for certain instance and then it's gonna decrease. So for metal, resistance increases, so specific resistance is directly proportional, so it increases. But for semiconductors, it actually decreases. So next question is, define the resonant vibrations. So the answer is going to be, resonant vibrations are the vibrations of high amplitude that are produced by the natural frequencies or the vibrations of a vibrating body, which is equal to the frequency of the forced vibrations. Resonant is a special type of forced vibration. Which characteristics of sound makes it possible to recognize a person without seeing him? Obviously the quality, the waveform of the sound which is gonna reach to your ear so as to produce the identification of a person without seeing the person. Next question is it possible for a hydrogen, this is the helium structure by the way, nucleus to emit an alpha particle? Give a reason. No, it's not possible for a hydrogen nucleus. It's just that for a proton, obviously, so as to give out an alpha, it consists of two protons and two neutrons. So it itself has got one proton and no neutron. So that's impossible. Let's go. Next question is question number 4A. Here we are given with the resistance numerical, and you have to find out the effective resistance. So what you have to do here is that you see here 5 ohm and 4 ohm, these are in series, right, which are parallel with 3 ohm. So you take out the effective resistance of it over here, because these both are in series, ultimately the effective resistance is gonna be 9. Since this equivalent 9 and 3 are in parallel, so 1 upon Rp would come to you 1 by 9 plus 1 by 3. Ultimately 1 by Rp is going to come you 9 upon 4. Okay, so which is nothing but 2.25 ohm. Then the total resistance is, this is 2.25 total effective and this is 8. These both are in series. Ultimately it's gonna be 10.25 ohm. That's your answer. Simple. Nice. Guys, if you're liking the session, please hit like the session. If you want more of such updates, please comment down below in the comment section so that I can understand that what is your requirement. State whether the specific heat capacity of a substance remains the same when there is a change of state from solid to liquid. 2 mark given below an example to support your answer. So the specific heat capacity of a substance changes when its state changes. And now the specific heat capacity of water is 4.2 joule per gram degree centigrade, while that of ice or the frozen water is going to be 2.1 joule per gram per Kelvin. Strike off the C number question since it's from magnetism. We don't have it in our syllabus. Next question is, why is a nuclear phenomena fusion reaction called a thermonuclear reaction? So this question I forgot to mark it, but this question you don't have it, so you can just strike it off. Strike off the E number question also. So now here are we with the second section 2, which is also belonging to the subjective part. This is very interesting. I personally love this subject, choice which you have to do. So let's see. Question number 5a states a body of mass 5 kg is kept at a height of 5 meter. It's allowed to fall and reach the ground. What is the total mechanical energy possessed by the body at the height of 2 meter, assuming that it's frictionless medium? So the answer is gonna be that the speed of the body when it's above 2 meter from the ground through 3 meter is v square is equal to 2 u square plus 2gh. Like this, they have calculated the v, which comes out to be root 60 meter per second. This is class 9 method. Since here it's asked, you can use your own method, but the thing is that the answer should come accurate. This is one such method. Another such method you can do by your own, but the answer should not fluctuate. That's the final statement. Okay. So the question states that mechanical energy possessed by at 2 meter height. So it's gonna be mechanical energy is the summation of the potential energy and the kinetic energy. So ultimately the answer is gonna come mgh plus half mv square. Just as in putting all the values, you will come to you as 500 joules. That's your answer. Fine. What is the kinetic energy possessed by the body just before hitting the ground? Just before hitting the ground, we know by the work energy theorem, mechanical energy is the initial potential energy. Okay, so it's gonna be mgh. Ultimately, mass of the body is 10 kg. 10 is the g which is given to us over here, and 5 is our height. Ultimately 500 joule is gonna be your answer. So you see, energy remains conserved. That's the point which you need to keep in mind. I told you. Fine. Next, you see here you have given uniform meter scale is in equilibrium. So calculate the weight of the meter scale. So first of all, metered scale's weight is always at its center, whatever might be. If it's half meter scale, the weight's gonna be at 25 centimeter mark. The total length is 100, it's gonna be at 50, somewhere here. Okay, so this side you need to calculate 50, let the weight be w, okay, which acts downward from the 50 centimeter mark. Now in equilibrium position, taking moments about the fulcrum, anti-clockwise moment is equal to clockwise moment, which is the principle of moments when the body is in equilibrium. Okay, ultimately calculating from the diagram, it's 14 to 30 minus 5. Okay, so it's 40 gf into 30 minus 5, so this distance 25, so it's gonna be 1000 gf centimeter. Then in the clockwise, w into 20 w gf centimeter. So you have to just equate them. W would come to you as 50 gf. That's the weight of your meter scale. Second question is given to you as, which of the following options is correct to keep a ruler in equilibrium when the 40 gf weight is shifted to 0 centimeter mark? Let's see which is the answer. Now, F is shifted towards the 0 centimeter mark. So that's gonna be your answer for this question. Alright, option was given to you, F is shifted towards 0 centimeter or F is shifted towards 100 centimeter. If you would put F into 100, then automatically equilibrium is gonna be disturbed. So that can't happen. So we need to do the just opposite. So the C number question, it states the diagram here shows a pulley arrangement. Okay, now you have to copy the diagram and mark in the diagram the tension of each of the string. So just you have to write here T T T, since the tension occurs just opposite. That's the thing which you're gonna write. Okay, next part is, if the tension acting on the stream is T, find the relationship between tension and effort. Since tension works in accordance to the effort applied, so the relationship is gonna be T equals to E. Simple. Second question was, what is the velocity ratio of the arrangement? We know that when the load is displaced by, 1 units, effort applied is gonna displace by 2 units. Ultimately, the answer is gonna come 2x upon x. If we consider x distance is moved by load, so effort is moved by 2x distance. Ultimately 2 is gonna come the velocity ratio for this question. Next question is, if the free end is moved through a distance x, find the distance by which load is raised. So loads, we know that when the effort is raised by the x distance, then ultimately load is gonna come half the distance. Ultimately it's gonna come x by 2. Fine. Getting easy, right? These are easy questions. You see, this 2018-19, these questions and also the 17 one, they're very easy if you see and analyze the questions. You know what difficulty comes when you don't read the book thoroughly, the key points of these questions. That's the point where you need to mend up. Keeping that aside, let's go towards the sixth question of our session. So this is, how does the angle of deviation formed by prism changes with the increase in the angle of incidence? Draw a graph showing the variation of angle of deviation with the angle of incidence at the prism at the surface. So this is the for the diagram. You just, if you have the pen, paper and notebook at your hand, just mark it, this diagram in your book. It's definitely gonna come in your exam. I'm giving you the guarantee. Fine. So the angle of deviation, it's gonna come, it's with the increase in the angle of incidence, it's gonna decrease, and to a certain extent where there's a del min, minimum deviation, and after that with the increase in the angle of incidence, the angle of deviation is gonna increase. So that's written over here, just read it. Next question. A virtual diminished image is formed when an object is placed between the optical center and the principal focus of a lens. Name the type of lens forming the above image. Okay, obviously it's gonna be a concave image because it's virtually diminished image. If it was virtually enlarged image, then you could have thought of the convex lens, which happens in case of between focal length and the optical center. But here it's told the diminished word, virtual diminished. This is the keyword. Mark it, very important. So the answer is gonna be concave lens. And next question is, draw a ray diagram to show the above characteristics. So we know this is the case of the, the instance for when there is the myopic lens. Okay, so that is the diagram which you need to draw. Next, you have got a question regarding to the lens formula numerical of the light chapter. This is, an object is placed at a distance of 24 centimeter in front of a convex lens of focal length 8 centimeter. What is the nature of the image so formed? This should have been given at the second part, so I'm gonna start from here. So let v be the distance. You can hold it 1 by v only, like that only you can calculate. Ultimately, by the lens formula, 1 by v minus 1 by u is equal to 1 by f. So ultimately 1 by v is gonna come 1 by 8 minus 1 upon 24. Ultimately b is gonna be 24 centimeter. Since it's 24 centimeter, positive 24, it means it's gonna be a real and inverted image for sure. The image is real inverted, and you have to calculate the nature, whether it's enlarged or diminished, by using the formula m equals to b upon u, which is 12 upon 24, nothing but 0.5. Since it's less than 1, it's gonna be diminished. So you're gonna solve 2 and 3 in order to get 1. This chronologically there's an error, but you need to solve it this way. Okay. Next question states, let's observe during the march past we hear a bass drum distinctly from a distance compared to the side drums. Name the characteristic of sound with the above observation. Obviously, the thing is that which distinguishes they're different in pitch and loudness. That's the answer. Since they have got the different pitch and amplitude, ultimately the loudness gonna matter. That's the distinct point. Second question states, give a reason for the observation. Now, the sound heard from the bass drum is obviously going to be of large amplitude. It's going to be very loud sound which you're going to hear, of low frequency. It's gonna be a very gravy sound, while that of a snare drum or the side drum, that's gonna have a high pitch or a high frequency. Keep in mind. Next question, this is a very common question. You can mark it very important and practice it immediately in a notebook. Next question is, a pendulum has got a frequency of 4 vibrations per second. An observer starts the pendulum and fires the gun simultaneously. He hears the echo from the cliff after 6 seconds of the pendulum. If the velocity of sound in air is 340 meter per second, find the distance between the cliff and the observer. So things which are gonna happen is that 6 vibrations, you're gonna calculate it. Since 4 vibrations per second, 6 vibration, ultimately time would come to you as 6 by 4, which is nothing but 1.8 seconds is the total time taken. By putting the formula of echo, you're gonna solve V is equal to 2d upon t. Ultimately d is gonna be Vt upon 2. So V is given to you 340 into 1.5, which is your time, upon 2, which is nothing but 255 meter. That's gonna be your answer. Next question is, two pendulums C and D are suspended from a wire as shown in the given figure. Pendulum C is made to oscillate by displacing from its mean position. It starts that D also starts vibrating. Name the type of oscillation C will execute. C would obviously execute, my friend, the free vibrations and damped vibrations if there is a resistance in the medium. Simple. And the part 2 is that name the type of vibration that D is gonna execute. D is obviously gonna execute a forced vibration because of the frequency of the C which you're implying, and ultimately D is coming in phase with it, although not resonant in this case. Okay, since their length are different, they're not having the same frequency, no resonance in this case. But the thing which is gonna happen is they're coming in sync. That is the main thing. Okay. Next question is given to you as the, if the length of D is made equal to C, then what difference would you note in the oscillations of D? Simply you would write that the amplitude of vibrations is gonna increase simultaneously because at that instance it's gonna come in resonance. Next question is, what is the name of the phenomena when the length D is made equal to C? It's gonna be resonance, as I said you. Okay, next question. Write question 8 says write one advantage of a connection electric appliance in a parallel combination. So many advantages, my dear. In a parallel combination, first of all, every appliance is independent. You are the king of yourself in the house, right? Because one appliance doesn't depend upon the switching on and off or the other appliances in the system. Moreover, the thing is that the potential difference or the force that is driving the current remains the same. So no appliance is gonna be glowing. See, in your home you have got so many appliances and lights and bulbs. It's not that one bulb will glow at higher intensity and one with lower intensity. Both will get distributed and you're gonna get an optimum. That's the advantage. Okay, next question is, what characteristics should a fuse wire have? Obviously, for a fuse wire, it should have a very high specific resistance and a very low melting point so that it easily breaks the circuit when there is a crossing of the safe limit of the current in the appliance. Surely, the circuit breaks off and you and your family, your full home is safe from electric shock. Simple. Next question is, which wire in the power circuit is connected to the metallic body of the appliance? The thing is that which wire in the power circuit is connected to the metallic body of the appliance? So it's gonna be earth wire. D question, you strike it off. It's from dual circuit system, which we don't have. So now C question, it states that here you're given a diagram in which you have to see that very neat and clean diagram is given to you. Now you have to find the resistance of the circuit when the key K is open. Okay, so when you're putting this key K in open, the thing what is going to happen is that current is going to come from this positive end and it's going to come here up to 2 ohm. Then since it's open, it's going to say bye bye current. by path. I'm not gonna take you, and it's gonna straightforward come towards this path, and it's gonna complete. This is the total equivalent resistance of this case. So ultimately what's gonna happen is that total terminal voltage is 5, and this is your internal voltage. This would sum up to give you ultimately the total resistance of the circuit is 5.5 ohm. Now we know by Ohm's law V is equal to IR. From there I is equal to V upon R, which is nothing but 3.3 upon 5.5, which is nothing but 0.6 ampere when key K is open, right? When it's closed, what is happening? Current gets two paths, either from 2 ohm, 3 ohm in series, which is in parallel with 5 ohm. That's the case. So you're gonna calculate in that way, which is nothing but RP is gonna come in this case as 2.5 ohm. Here it's 2.5 ohm, and along with 0.5 it's gonna come to you as 3 ohm as the total resistance. Ultimately the current drawn would be nothing but V upon R, which is 3.3 upon 3, which is nothing but 1.1 ampere. That's gonna be your answer. Okay, so next question is question number 9 say, which is define calorimetry. Okay, so calorimetry you will write it's the science of measuring the heat exchange in the system with its surroundings. That's the simplest answer for the one marker question. Next question is name the material used for making a calorimeter. Obviously a copper sheet is gonna make a calorimeter. Alright. Next question is why is a calorimeter made up of thin sheets of the above material? Answered in number 2. It's because copper is a good conductor of heat, right? Good conductor of heat and electricity both, and it acquires the temperature of its constituents. Thin copper wire has got a low heat capacity, so it takes a small amount of heat from its contents. That's gonna be your answer. Next question is melting point of naphthalene is 80 degrees centigrade and the room temperature is 30 degrees centigrade. Sample liquid naphthalene at 100 degree is cooled down to its room temperature. Draw a time graph representing the cooling. The graph will be mark the following things which consents to the freezing process. Then ultimately what's going to happen is that liquid naphthalene at 100 it's gonna come down at 80 degrees centigrade. Here it's gonna undergo freezing until there is a change in state, and we know change in state there is no change fluctuation in the temperature. Ultimately the thing which is gonna happen here is that your at certain stage it's gonna once again decrease down to room temperature over here, somewhere here. So this is gonna be appropriate temperature versus time graph. C question you don't have since it's from latent heat, I suppose. Yeah, surely latent heat. So this question you would be not be having since latent heat simple numericals are also even cancelled. Next question is question number 10. Say this is cancelled, cancelled, cancelled. So guys, with this we end up with this 2019 paper ICSE physics totally solved. So if you like the session until then, and if you've survived yourself to stay till the end, please hit like the session, subscribe the channel, and I'll be very happy to read down your comments. So please do comment below whatever is your opinion. And with this is Nizam signing off for the session, your host at ICSM One Shot. Thank you for watching. Peace.